Sister Christian. Did you get the email? Okay, good.
Thank you.
Uh-huh. All right, let's get going again. So I got an email yesterday from the chair of the department letting us know that they're replacing our copying machine. We're going to get new ones, and this is why. This is what happens when you send a print job to the machine. It comes out like this. So I'll hand these to you, but I've also emailed you a copy of this. All right. Sorry. Well, it looks like there's one decent one in there. One, two, three, four. Yeah. Starting a trend. Let's see, 3, 4, 5. Okay. Hopefully there's enough here. You got the best ones there. There we go. Perfect. And one for me. All right. So I said that I could let you work on this for half an hour and then we could talk about it. That's option one. And then option two is that I can just go through this. So what would you all prefer? What would you all? You want me to go through it? Okay. I sent an email out, very important, that this is not the only thing that will be on the test, all right? There will also be problems from dimensional analysis, which is where you're doing conversions. So make sure you review your homework problems where you were asked to go and do, metric to metric, metric to imperial, imperial to metric, and then something that has like square units to square units. Not so much, no. I wouldn't worry about that. So just the conversions. Now on the conversions, I will provide you with all of the conversion charts, the metric one, and then all the ones that go from like feet to meters and things like that. So that will all be given to you, but you need to know how to work them out, okay? All right. All right, so since I'm going to be doing these problems, I guess I'll do them on camera. Yeah, I'll just do them on camera. Do we have sounded like a pretty strong majority. Yes, you want me to work through this?
Yes. Before that, on the conversions,
yes.
Can we do like two, maybe these squares, square millimeters?
Yeah, when we get to the end of this, we'll do that. Okay, so I'm going to work very fast here. So we're not going to be going around with sticks and asking questions because I want to get through this. And I have, an hour. Your exam will be similar to this, maybe not the same length as this, but you should have enough time. And remember, when we take the test on Monday, we're gonna have half a class first, and then we're gonna take a test. So on the first half of the class, we're actually gonna cover new material. I hate to do it that way, but that's the way we're gonna have to do it. New material, then the test, then after the test you can leave, all right? All right, so first one. We want to write the equation of the line which is perpendicular to this line and has a y-intercept of -7. So we are trying to find the equation of the line. The line we're looking for is this one. Okay, we're trying to find the equation of a line. What we know is that we must be perpendicular to this line, but we need to have a y-intercept of -7. So that first part, saying that y-intercept is -7, means that I already know that b has to be -7. And then I need to just figure out what the slope is. But what can I do to figure out the slope? If I have to be perpendicular to that line, then how can I figure out the slope of this line?
-1 over
Yeah, so we need to figure out what the slope of that line is first, and then we're going to flip it over and change the sign. So I need to solve for y here. So what I do is I move the 4x to the other side. I divide both sides by -3. I get y is equal to, what is that going to be in front there of the x? Over here, well, I'm saying for this line, if I just do this over this, it's positive, isn't it? Okay, so this is the equation of that line written in slope-intercept form. So the slope of this line is this, right? Which means my slope over here needs to be what? -3 over 4 x minus 7, because it was perpendicular. If it was parallel, if it said parallel, then I would use 4/3 again. Okay, next question. Are these two lines parallel or perpendicular or neither? So they give you two lines. Can you look at the first line, L1? Can you tell the slope of this line yet?
Yes.
Yes, because it already looks like y equals mx plus b. So the slope of this line is what? 3/4. Okay, now for line 2, can you tell the slope of that line right away? Or do you have to do something first? Yeah, you have to move this over. This term right here needs to come to the other side. So when you move that to the other side, it becomes 4/3 x plus 1. So you're adding that, adding 4/3 x to both sides. And now you can compare the slopes here. What's the slope of this line? 4/3. So are they parallel? No. Perpendicular? No, because these would have to be opposite signs. They're reciprocals, but they're not opposite signs. So the answer to this one would be neither. All right, I'm moving quickly. All right. Number 3. So the answer to number 2 is neither. For number 3, write in slope-intercept form, find the x-intercept, the y-intercept, and graph the line. 4x minus 3y equals -12. Okay, so first, I need to write this in slope-intercept form. What does that mean? Solve for y, right? Solve for y. So I'll move that to the other side, the 4x to the other side, and then I will divide by -3. So this will give me y equals 4/3 x, and then plus 4 right here. Okay, so that's the first part. I've written it in slope-intercept form. I need to find the x-intercept. So how do you find the x-intercept? Set y to 0, right? So so this is the answer to the first part. Find the x-intercept. You set y to 0 and solve for x, right? Now, when you set y to 0 and solve for x, do you use this equation or that equation, or does it even matter? Yeah, it doesn't matter which one you use, but I like this one more. I like to go back to this one, and that's the one I'm going to use for this part. Okay, so I'm going to set y to 0. When I do that, I get 4x equals -12. Remember, you can go back and watch this on video later. You know, I know I'm going fast. I set that, y equals 0 kills that off, so I'm left with this. Divide both sides by 4, I get -3, right? So I have an x-intercept of -3, 0. How do we find the y-intercept? Set the x to 0, okay? So now I set the x to 0. And solve for y. Okay, so I'm going to go back again to the original equation. When I let x be 0, I get -3y equals -12. Divide both sides by -3. Get y is equal to 4. So my y-intercept is 0, 4. Now, I already knew that, didn't I? Like, I could have used this one. There's the y-intercept right there, okay? But I worked it out anyway. So now finally, I need to graph it. And when you graph it, I say make sure you label your intercepts on the graph. So when you go to graph this, you have two options at this point. You can use this one and start out at 4 up and then use your slope, right? Rise over run. Or don't you have 2 points? -3, 0. I put the point, I label it, -3, 0. And then I have another point, 0, 4. I label it, 0, 4. And I draw a straight line through the two, and I'm done. The other way would be to use this, start at 4, and then go up 4, over 3. And then draw, and you should draw the same line. Okay, number 4 and number 5 are the exact same thing. All right, so I'm going to skip those and let you, and if we have time and you want me to go through, I'll go through it at the end. I want to make sure I get everything else covered. All right? Okay, number 6. Dan plans to diet. Look, this is what we talked about today, isn't it? Dan plans to exercise and diet to prepare for a triathlon. If his starting weight is 178 pounds and he can lose 0.31 pounds per day, then answer the following. First, what's the linear equation which gives Dan's weight? I'm going to put my weight. In terms of the number of days Dan has been training. All right, so for number 6, we're going to put our weight as a function of x. Here, x is the number of days. And what is the equation going to be? Or what's the formula here?
0.31x.
Okay, 0.31x. Is it positive or negative there?
Negative.
Negative because losing weight, right? And then that's your variable part. And then plus what's your starting weight? 178. Okay, so that is your linear function. Starting at 178, losing 0.31 pounds a day. Okay, part B, that's part A. Part B, how much will Dan weigh in 2 weeks? Be careful there. 2 weeks.
14.
Yes, so you're going to use 14 for X, not 2, right? Because this says it's in days, right? 0.31 pounds per day. So for part B, we want the weight after 14 days minus 0.31 times 14, then plus 178. I'm getting 173.6, that's fine. 173.6 pounds. LBS for pounds, or you can just write the word pounds. Okay, part C. About how long will it take Dan to reach his goal of 162 pounds? So now what it's saying is, when is the weight function equal to 162? And so we solve this equation for x, which means first we're going to subtract 178. Subtract 178. This will give us negative 0.31x equals, what's that, negative 16? And finally, we divide both sides by negative 0.31. So x is, let's see here, approximately 51.6. You can round that to 52 if you want, okay? what?
Days.
Days. Number 7. That's what we ended with today, right? 12 gallons of pure water. Draw a picture. 12 gallons of pure water, 12G, is mixed with 5 gallons of what percent acid? 25% acid. You mix them. How much is in the mixture?
17 gallons.
Okay, we should have 17 gallons, and that is from, 12 and 5. Now, we need to figure out the percent acid here. So we need to figure out how many gallons of acid are in here. 0, right? 0 gallons of acid because it's pure water. Okay, here, how many gallons of acid are in here? You go 0.25 times 5 gallons, right? And what's that going to be? 1.25 gallons of acid are in this mixture. So how many gallons of acid are in this mixture when you mix them all together? Yeah, it's still 1.25 because you're adding no gallons of acid from there. So 1.25 gallons of acid. So what is the percent then? You take 1.25 and you divide it by 17, right? So 1.25, divide that by 17. And you are now looking at approximately 0.0735, something like that. So we're going to say about, 7.4%, roughly. I'm not going to be real picky about, the rounding part. Are there any questions on that? We've done a few of those now, right? So that kind of is flowing pretty nicely here. All right, number 8. This one is best, I think, if I just put it up on the board. And this is very much like the problem we did in class. Very much like the problem we did in class already. Boy, this is going a little faster than I thought it was going to go. Okay, so I'm going to zoom in on this so we can see it. Is that the same exact problem? It might be. Let's see. What's f of 2? So what happens here? When we plug 2 in, what do we get? 4. This means plug in 2 for x, what comes out? 2 for x, what comes out is 4. Okay, what's f of negative 1? So go to negative 1, you're at 1, 2, 3. This seems like the same problem. What's f of 0? 4. Go 0, which means stay here, up 4. What's f of negative 4? 0, and then f of 5 looks like negative 1 to me. So it's asking for the next one, for what value of x does f of x equal 0? X is negative 4. So this is where, this problem right here, what we're saying is where is your y value 0? So where is that 0? Like that, you come over here, there's the point, and that happens at x is negative 4. And where is the function's value 1? It is 1 at x is negative 3. And you can do that by going to 1 unit up, seeing where we hit the graph, coming down and saying that's negative 3. So this is going to be a pretty short test. Would you agree? I mean, this is going to probably go, I mean, you won't do it that fast, I don't think, but it's going to be, you think it'll be pretty reasonable? I still need to do the conversions, but this part we're done with. Okay? All right, conversions. Let's actually just go to the homework for this, and it's going to be way back here. Feel like
Is there going to be like a word problem conversion?
there could be, but if so, it's only going to be one of them. I'm more concerned about you getting the conversions down. So let's see about these here.
Can you do a squared one?
Yeah, so let's do a metric to metric, then we'll go metric to imperial, imperial to metric, and then we'll do a squared conversion, and that'll pretty much cover it. All right.
Okay.
So here's a metric to metric, right? So how do we go from kilometers to centimeters? 104 kilometers to centimeters. To do this, I would use the chart. So I'm going to bring up that chart. I think I already passed it, sorry. Where the heck is it? There it is. We're going from kilometers all the way to centimeters. So we move to the right 1, 2, 3, 4, 5 places to the right. Right? So we're going to take the decimal place, 104, and go 5 places to the right. So 1, 2, 3, 4, 5. Put the decimal here. Fill this in with zeros. So this is going to be 104,000,000 centimeters. So it's like 10,400,000 centimeters. Make sense? So metric to metric was the easier. Let's see here. How about we go 10 kilometers to miles. I'll put it right here. 10 kilometers to miles. So we need the conversion factor. So I'm going to go up here to my conversion factors. Oops. There we go. So is there a way? Oh, there's a direct way to get from kilometers. Let's not do it that way then. Let's do kilometers to yards. Yards. So how can we get from kilometers to yards? You all remember how to do this? You do 10 kilometers over 1, and then you start trying to get your way there. So how can we do this? Kilometers, the only thing we have here is kilometers to miles, right? So we can go from kilometers, just kind of thinking through this, we're going to go kilometers to miles, and then once we get to miles, we can go where?
Miles to foot.
Miles to feet, and then from feet we can go to yards, right? That's kind of the track we're going to go. Okay, so let's first do kilometers to miles. So to do that, I need kilometers down here and miles up here, because then my kilometers will cancel. So what is my conversion that we're going to use here? This one right here, right? So 1 mile on top and 1.60934 kilometers on the bottom. So my kilometers will cancel now, right? Now, we want to get from miles over to feet. So miles on the bottom, feet on the top. And we go over here, miles to feet. So what goes where? 1 goes where?
The bottom.
Bottom, and then 5280 goes up top. Miles will cancel. Finally, we have to get from feet to yards. So I multiply this by feet here on the bottom, yards on top, and my conversion here is that 1 yard is equal to 3 feet. So where does what go here? Feet goes on the bottom, so 3 on the bottom and 1 on the top. And my feet will cancel. Now what we do is we just get on our calculators and we just multiply all the numbers straight across. So 10 times 1, you don't really need that, times 5280 times 1. So let me do all that. Well, that's just going to be 52,800 on the top, and I'll have yards. And then over, what am I going to have on the bottom?
4.8.
Yeah, this times this times this times this. So you don't need the ones, but you know, they're there. So 1.609344. I still need times 3 here. So 4.828032. And now divide those on your calculator.
It's like 10,900.
Yeah, about approximately 10,936.13 yards. Metric to imperial, right? Any questions on that? All right, let's do let's do, that was metric to imperial. Let's go imperial to metric. How about 7.5 cups equals how many milliliters? So this is a measurement of volume, and so we have to look at our table here. So how can we get from cups to milliliters? Tell me about the path to go from cups over to milliliters. First we can go cups to where?
Fluid ounce.
Yeah, so I have a couple of things here. I can go cups to tablespoons. I can go cups to ounces. But I'm trying to get to milliliters, right? So do I have anything that goes directly from tablespoons to milliliters? I don't. But I do have a way of getting from ounces, right? Ounces over to milliliters. So we should go cups to ounces, right? And then ounces to milliliters. Make sense? Everyone see that path? Okay. So first we write down our unit ratio, which is just this over 1. Now, we want what to cancel? Cups, right? So I want cups down here, and on the top I'm going to try and get to ounces. So ounces here, and our conversion for this is that what? 1 cup is 8 ounces. Okay, so that should work. We should be able to cancel the cups. Now I need to get my ounces out of here, so ounces on the bottom, and I want to get to milliliters. And my conversion for that is the top one there. That 1 fluid ounce is 29.57353 milliliters, and that will allow my ounces to cancel. So it looks like for this one, all I'm going to be doing is multiplying across the top, because the bottom is just 1, 1, 1, right? 1 times 1 times 1. So 7.5 times 8 times 29.57353. Looks like I'm getting about 1,774.4 milliliters. Again, does this make sense? So the rest of the review that I had given you, right, was about 8 problems. So I would expect this to be probably about 8 problems here, maybe 7. I might, because there's 3 that are kind of the same. And then you're going to have an additional, 5 problems of conversion. So this does make up a good chunk of the test. I'm going to just weight each problem equally. So make sure you're comfortable with this. Last thing to do is a square unit to a square unit, right? So let's go, how about 3,244 square feet over to square miles. Wow, it's going to be a tiny number. Let's make this number a little bit bigger. Let's add some numbers on the front of it. 501 in front of that. So we actually have 5,013,244 square feet over to square miles. All right. So we look at our conversions, right? We're trying to get from feet to miles, right? But square units. So do we have a conversion to go directly from feet to miles? Mm-hmm. We do, right? This is it right here. The problem is that we have a square unit. So the way you start this out is you write down 5013,244 miles, just 1 mile over 1, and then you write next to it again 1 mile over 1. So that way you have your miles squared. And that means you have to cancel it twice. Question already? No?
Yeah, because it's 50.
Yes, I'm sorry, yes. Don't know why I put mile. Hold on. This should be feet. Is that what you were confused about? Mm-hmm. Okay, thank you. Yeah, thank you for that look, because I could tell I had done something wrong. Okay, so feet squared, right, needs to go to miles squared. So I rewrite this as this feet, and then times another foot over 1. Now my conversion. So I'm going to have to use 2 of them, right? 1 to cancel each of the feet. So the first one that cancels this feet is this one right here. I have feet on the bottom, miles on the top, and it's 5,280 feet is 1 mile. And then I redo that again. 1 mile is 5,280 feet. And that way this feet unit and this feet unit cancel, this feet unit and this feet unit cancel, and we are left with mile, right? Mile times mile, which will give us our miles squared. All right?
Could you explain that really fast?
Okay.
Why did you put the feet?
Why did I put the feet twice, right? Because when they put feet squared here, right, this is a measurement of area as opposed to length. So in order to get feet squared to cancel, you have to cancel both feet, right? So I have to come in with 2 conversions. Yes?
So what's the final answer? Is it just 1?
No, the final answer is this times 1 times 1. So that number over these 2 numbers multiplied. Okay, so I haven't done that yet. Let me do 5280 times 5280. So if on my calculator, the top would be this, and the bottom, when I do 5280 times 5280, I get a big number, 278,78400. And this answer is going to be miles squared. Okay, so this 1 times 1 times 1 times that is just this, and then these multiplied is this. Go ahead and do that on the calculator. I'm getting approximately 0.179 square miles. What do y'all think? So this past weekend I had to help my brother-in-law move. He's going through a divorce, so I had to go drive up to Lubbock, Texas. I've never taken that drive before. Has anyone ever driven to Lubbock, Texas? It's a pretty long drive. I mean, I don't drive that much, so it's about 6 hours there. So it's about 400 miles to get there, right? So you're still not out of Texas. That's crazy, right? You can drive for a whole day and still not get out of Texas. So driving there and back was about 800 miles, right? So I was talking to my wife, because on a 6-hour trip both ways, it's a lot of talking, right? So I was telling her that because we were just like looking at just how big everything is, right? How just all this open space. So I said, okay, if you take a golf ball, all right, and say that that's the sun, okay? Like take our sun that we have out there, right? And say it's the size of a golf ball. Then the earth is a grain of sand that's about 12 feet away from it. Okay, so to give you some idea, do you get some idea of how far that is? Like, here's a golf ball, 12 feet, maybe that wall. Grain of sand, that's the earth. Okay, the next nearest star, okay, the next nearest sun star, right, is 800 miles away from this golf ball. So if you look at our sun and you start looking around, like, we see all these stars everywhere, right? Which are all suns. So if you go and you say, hey, where's the closest sun to us? And start traveling to it, right? Give you some idea of scale, it would be 800 miles away from that golf ball. That's a very, very long distance, yes? Why am I talking about this? Because these distances, like you get some idea of like how big something is, right? Like we're talking about 5 million feet. 5 million feet, that's a lot, right? Seems like a lot, but this, if you look at that many square feet, that's only like 0.1 square miles. Remember when that plane got lost a couple of years ago, that plane that just kind of was flying and disappeared, and they still don't know what happened to it. Remember that? They never found it? They were trying to search the ocean, you know, they're like, we've got it down to like 15 square miles. And people are like, well, why can't you find it? Well, that's a huge amount of area, right? 15 square miles. This is not even 2/10 of a square mile, and it's a huge amount of space. Okay, so I was just thinking about golf ball, just how vast everything is. It's kind of, she said, it makes you kind of feel like, I said, a grain of sand, right? And she's like, yeah, pretty much. Okay, we're done. Yes? You all happy? We'll be here on Monday. We'll start a lecture. I know it's very hard to like absorb information, then take a test on something, but that's the way we're going to do it. That way I won't be rushing anyone.